Okay, so we're going to talk a little bit about some of the benefits of the technology. So we look at the design, we see wide directivity, and this is one of the key aspects. Wide directivity from a large object. It doesn't matter if it's a small panel or a big panel. We can go to very high frequencies.
Hey, my 21s have large directivity, and it's a large object.
Narrow directivity.
No, very wide, as long as the frequency is low.
That's
the
high
benefit.
Yeah, up to the highest frequencies, we can radiate wide directivity.
Defined as,
for example, 160 degrees across the front.
Up to
depending on the applications, but up to 15 kilohertz and above in some cases.
Right. So when I run the polars on this, I don't get quite to 15.
Yeah.
But I guess it's a function of the size of the motor, size of the panel, and the embodiment of the actual what's the embodiment of the technology? But I have seen it get up there.
Yeah.
And I've seen some of the other small BMR type speakers get way up there.
Mm-hmm.
And
I mean, this guy, as we've seen in the measurements, we've been measuring this guy over 130 dB, at distance, or even above 100 dB.
Sure.
Quite far out. So this is designed for very high power applications, and it's also it's kind of the first design of its kind along this route. We already have had conversations about improvements.
Sure.
That can come in the future, but this design had to be incredibly reliable, and it had to be high power handling and high efficiency. So in terms of the high frequency wide directivity. We made a decision at the time that we wouldn't push it. We'd trade that off a little bit for some of the other aspects until we had got a better understanding of this design.
It's quite funny. I haven't run into this question for a lot of years, but here we are in 2015, and people still confuse efficiency with sensitivity.
Yes. And
actually, this panel is extremely efficient because. Sensitivity is literally measured on some axis to the device, because maybe you have a two-way device or a three-way device. You have to decide where to put the microphone to make the measurement. And it's usually done with a 2.83 volt level and then measured within the operating bandpass of the device.
Yep.
And you get a measurement. But people correlate that with efficiency. And actually, that's incorrect.
Yep.
Efficiency would probably be more related to, say, the power response of the box. Mm-hmm. So if you have a device, you have a 360-degree circle around it, and then 360-degree in the vertical axis, and then on every single axis, you have a sphere.
Yep.
How much energy does the device put into that sphere? Using 2.83 volts.
Yep.
And if you measure these, there is actually equal energy going out the back than going out the front.
Yep.
Which can be problematic, and we need to have ways of dealing with that.
Yep.
Not in every application does that work, but looking at it that way, you can. It's no problem saying this is probably the most efficient audio device I've ever measured.
Yeah, my understanding of efficiency is power out divided by power in. So exactly as you say, a single point measurement is going to tell you perhaps the sensitivity at that angle, but in terms of efficiency, you have to consider the total radiation passing through a sphere of a given surface area.